want to tell you that it's a great pleasure to be here after these many years of fruitful collaboration with Professor Mazzetz and everybody at Ioffe. And I especially want to thank Raphael Aptica for his invitation. What I'm going to tell you are my recollections of the early history of the field and how the puzzle of gamma reverse took so many years to be resolved. I was interested in detecting astrophysical transients back in the late 1960s, before gamma reverse, when Sterling Colgate published his prediction that supernovas should emit a burst of very high energy gamma rays within a few milliseconds. And his prediction was confirmed in a curious way in the supernova 1987A, when the neutrinos were discovered with a several millisecond flash. So in 1969, I started working on building a balloon borne instrument to look at Colgate's supernova gamma rays of very high energy. At that time, I was very interested in solar physics and solar cosmic rays. I even gave a talk in Leningrad in 1970 on this subject, and before I knew anything about Ioffe. And I had a detector on the interplanetary monitor platform to look at solar X-rays between 0.1 and 1 MeV. So between 71 and 73, I accumulated a number of intense increases that nobody could confirm. I asked everybody I knew connected with NASA for confirmation, but of course they had gamma ray detectors, but they were collimated and didn't, of course, happen to be pointed the right place at the right time. Meanwhile, well, let's see, what is my microphone that changes volume? Good, thank you. Meanwhile, the VELA program, of course, as you know. Now, the point is, the VELA events were very jagged and chaotic, whereas the VELA program was designed to detect thermonuclear weapon explosions in space. And the predicted time history of an H-bomb was the rise in 1 millisecond and the decay very smooth. You'll notice, you can't see it from here, but the time history starts out and expands geometrically. They only published the 32 millisecond count rate up. I guess that 1 millisecond was some sort of military secret. But clearly, these were not nuclear weapons bursts. And I rushed through my IMP data, and I found 6 events of their list of 14. And so I co-authored the first paper from the scientific community on this subject, the second publication on gamma reverse. Meanwhile, someone in San Diego, California, found one of our common events, OSO 7, and it was collimated, and they had a direction, and that agreed. The significance was that that agreed with the directions determined by timing from the VELA spacecraft one to another. The other, to me, the other significant fact was that that event came from the North Galactic Pole, not the galactic equator, like all the Giacconi X-ray sources. And that was a rather prescient moment. Well, we flew our Colgate search in 1974 and 5, and later on, the people at Marshall with the GRO BATSI experiment, the calculated that the total number of gamma bursts per year was 660, with a huge detector, which meant less than 2 a day, which meant less than 1 a day above the horizon for a balloon experiment. So we saw 0, so that was compatible. But it didn't help. I went to NASA headquarters and I proposed the creation of an interplanetary network. I asked that any NASA experiments under construction, don't wait for a whole new round of proposals, modify whatever is under construction so that we can do at planetary distances what Los Alamos did in Earth orbit. And we got a number of missions. IC-1, International Sun-Earth Explorer 1 and 3, Helios 2. Helios 2 is in orbit around the sun. And one cute event in 1978 was an event that took place when Helios 2 was exactly behind the sun, 2 AU from the Earth. But the data were recorded, telemetered later, and the gamma burst source was, let's see, in the next slide, we showed that all of our source directions were empty down to the 23rd magnitude. And that, of course, didn't help anybody figure out the source population of gamma bursts. I even myself went to Kent Peak and conducted a deep optical survey, but no luck. Then, a man from Toulouse named Vedrin heard my talk in 1973 at the Cosmic Ray Conference, and he said the Franco-Soviets collaboration with Moscow, and they had Pioneer, Venusian spacecraft, and NASA had something called Pioneer Venus Orbiter. So the network that I proposed consisted of Helios around the sun, several spacecraft near Venus, and of course several near the Earth. And what we discovered was that one event fit within a minute of arc to the supernova remnant M49. And this confused, this started, instead of helping solve the gamma ray burst mystery, obviously, this started the confusion that lasted for nearly 2 decades. I claimed, and I was the only one to publish the claim, that the March 5, 1979 event was not a gamma ray burst, but a different transit from a different class of sources. And this was based on the fact that, like an H-bomb, it had a 1 millisecond rise time. It had a smooth decay. No other gamma ray burst was like that. It had an 8-second period of tail. No other gamma ray burst was like that. Golodetsky started finding SGR events, and one fit right on agreeing in source direction with this. No other gamma ray burst repeated with baby-sized events, and therefore this, to me, was clearly not a gamma ray burst. The next slide shows the rise time in 1 millisecond to maximum intensity saturated, and the time history, which you're all familiar with. John Lawrence from Los Alamos found the 3rd SGR, and in the next slide we see we also reanalyzed the March 5 source, and instead of including all of N49, it was within 5 seconds of the center. Curiously enough, a conference was organized in California to investigate the ramifications of that source not being at the center. Maybe neutron stars are flying around at such speeds that that's what accounts for the isotropy, and they're all really very close. Everything imaginable was investigated by many dozens of solar models. Anyway, the three NGP, the three SGR sources, two of them were in the galactic plane. The third one is the one from the large planetary Cline. So clearly, SGRs were a galactic phenomenon. There was a guy named Brad Schaefer who found an optical spot in a 1928 Harvard archived optical plate right in the middle of another gamma-ray burst source position. And that created the speculation that gamma-ray bursts go off every 10 or 50 years. And Ricker at MIT built an entire sea-level array of optical telescopes to look for bright flashes from gamma-ray bursts. And he found only airplane strobe. Nevertheless, he proposed and built the heading high-energy transient experiment based on that principle of reorienting after a bright optical flash. Fortunately, it failed at launch because it would not have done anything. And meanwhile, Bevno Sachs found, as you know, the discovery of the cosmological correlation and with X-ray detectors. So Ricker at MIT rebuilt and made Heady 2 based on gamma rays and X-rays. And it worked fine. And it was at Earth orbit, so it didn't help the interplanetary network. But I went back to headquarters and again proposed the network be rejuvenated with NEAR, N-E-A-R. That's the Near-Earth Asteroid Rendezvous. And of course, asteroids are out past Mars, so that was an excellent long baseline. Meanwhile, I proposed an experiment for solar pole, which you never heard of, because it was two interplanetary missions, one going over the North Pole, heliocentric, the North Solar ecliptic region, the other going south. And after it was built, NASA canceled the funding and it was never flown. The European one, of which Kevin Hurley was PI and I co-I, that was renamed Ulysses, and that became the flagship of the Interplanetary Network until a few years ago. So with Ulysses and NEAR and Earth orbiters, we had a large number of high-precision GRB sources located in time for their afterglows to determine their cosmological redshifts, as did Heady, as did Bevno Sachs, and Konus was a member of that interplanetary network. And the next slide, this is Edward Teller is on the right, the man who co-devised the hydrogen bomb after World War II. And he, of course, was central to the Vela program at its creation to look for hydrogen bomb tests in space. And he and the people of Livermore made an instrument to search for the launches of distant intercontinental ballistic missiles. He donated this to the GRB program at Livermore. Hysup Park was PR. And Akerlof at Michigan was one of the many people who built instantly reorienting sea level telescopes using the GCN system devised by my colleague Scott Bartholomew at Goddard. And in 1999, I believe, 20 years ago, Akerlof was able to focus on the afterglow of a gamma ray burst within 10 seconds of the onset of the gamma ray burst itself. That was an award-winning feat of technology based entirely on the use of GCN, which of course Nature magazine once praised Scott Bartholomew by inventing the first research tool based on the World Wide Web. So after Beppo Sachs made its discovery, then of course, as you know, gamma ray bursts were clearly cosmological and giant flares were clearly galactic. And Raphael has already told you about our creation of the Konus-Wind. That was, I believe, the first Russian experiment on a NASA spacecraft. And it is still working perfectly. And I'm very proud to have been part of that. And I thank you all for your attention.
Any questions? No questions?
Okay.
So I have a question. When was the last view of GRB?
Sorry. When was
When you detected the last view of GRB on wheel spectrum?
the echo? I can't just tell. Oh, the Vela system? Oh, that lasted for many years. Oh, yeah.
When was
I
that?
don't remember when the last one, but it was, yeah, freaks.
So you say all of your source error boxes are empty, but what about host galaxies? Were they so large you just expected there to be galaxies? Why was that excluded?
No, that picture was typical. We didn't find anything worth investigating. And probably N49 led everybody astray anyway, because that was only a few years after the whole program began.
But isn't that a puzzle since we now associate long GRBs?
Well, the point is the data could not be collected instantly. By the time the telescopes, like Kitt Peak and Chile and everything, it was weeks old, months old information.
That tells us why you weren't finding afterglows in the star, but the host galaxy would still be there. So that's why I'm wondering.
No, I don't recall that anybody did that.
I'm relatively sure that in typical cases the host galaxy will be fainter than the follow-up observations that they actually perform. So I think you mentioned something like 2032 or so.